So for this one, we did talk about a little bit, and then go back to this previous one, setting these up using a solution diagram or a solution map, where you set out the units that you're starting with and the units that you want to get to, and then figuring out a series of conversions that gets you from A to B. So that's what we did here. We're just trying to get from centimeters to yards, and there's a lot of different ways that you can do that. Ideally, you want to try and find the shortest one, but aside from like weird edge cases, no one way is better than the others. If it takes 10 conversions, as long as you're not rounding anywhere, it should be about the same as doing one conversion. Ideally, one conversion shorter. For this problem, what are we given? Now, centimeter cubed is a unit of what? Volume. Yeah. So it's a compound unit, right? It's made up of centimeters. It's defining a volume. So we're starting with this 9,255 centimeters cubed, and we want to get to gallons. And we are given a little hint that 1 gallon equals 3.785 liters. So one of the things that you can do here is you don't have to just work forward. It's like any puzzle that you might work on, Sudoku or something. You can either work from the end or from the beginning. Since we're given this hint of 1 gallon equals 3.785 liters, it's a suggestion to use that. So we can insert that into here because our final unit that we want to end up with is gallons. So maybe instead of just thinking about trying to get to gallons, this is saying, hey, I should try and get to liters first because I was given a conversion factor. I can go from liters to gallons. Now, how might we go from centimeters cubed to try and get closer to liters? Milliliters. Yeah. So this is one of those special ones where 1 centimeter cubed is equal to 1 milliliter. So if we convert centimeters cubed into milliliters, and then how do I convert from milliliters to liters? There's 1,000 in there somewhere. Is it 1,000 milliliters is 1 liter, or 1,000 liters is 1 milliliter? 1,000 milliliters is 1 liter, yeah. Do you have that? Oh, that's way over there. There's like a 1 liter bottle of hand sanitizer. 1,000 milliliters will fit in there. So I guess I'll just write it up here. Cool. And so that sets up every single step that we need. You just got to make sure that when you're writing it in here that you write the units in the correct spots. So centimeter cubed goes on the bottom, milliliter on top. So now I'm looking at milliliters, and I need to cancel out milliliters. So 1,000 milliliters goes on the bottom, 1 liter on top. And then 3.785 liters on the bottom, 1 gallon on top. And then you can multiply everything on top and then divide by everything on the bottom. So let me set this up so it's actually showing you the calculator. There it is. Can't. No, that's far enough over. Yeah. All right, so I can do 9,255. And then it's ones all the way across the top. So you can ignore all the ones. And then I'll do divided by 1,000 divided by 3.785. So 2.445155. How many sig figs should I have? 4. So we weren't told if this is exact. Oh, you can't see it because of this. So we weren't told if this 1 gallon to 3.785 liters is exact or not. So we should probably assume that it's not, but that's still 4 sig figs there. This is 4 sig figs. So yeah, we should have 4 sig figs. Interesting. I don't know why I got 2.445 instead of 2.446. Probably a typo. Wow, that spot is really squeaky. Okay, good? Yeah, all right. No? Confusion? Other questions? See some concerned looking faces. You have questions. No? Okay. Can ask me or one of the SIs later. So conversion factors for metric prefixes can be very easily made between the base unit and then another unit with a prefix. You can, once you get more familiar with these, make conversions between two different prefixes. The easiest way, though, is to just go back to whatever the base unit is and then go to a different prefix. So remember, prefixes are these guys in the front. This K, for example, is a kilo, so kilometer. And this method will always work if you put, the prefix goes on one side, multiplier on the other side, but it's that the one goes with the prefix. 1 kilometer. And that's 1 times 10 to the 3 meters, which is the same thing as 1,000 meters. Like I was saying, if you've got two prefixes, or if you have both these have prefixes, then you go from one prefix to the base unit and then to the other prefix. So if you want to go centimeters to nanometers, you might start with centimeters. So 1 centimeter equals how many meters? Yeah, centi means 1 times 10 to the negative 2, or 0.01. And then we want to go from meters then to, so meters to nanometers. So here I put the 1 with the prefix. And then how many, 1 nanometer is how many meters? Yeah, 1 times 10 to the negative 9. Nano, 9, both start with N. 1 times 10 to the negative 9. And part of the reason that you want to do it this way is because when you go and you look up nanometer on a chart, we'll flip up here real quick to wherever that chart was. Far away. Oh, there it is. On this chart for each of these prefixes, it gives it to you in how many meters would be, or how many seconds, or how many of this would be one of the micro unit, or one of the milliunit, so, or one of the nano. So nano means 10 to the negative 9. Were you telling me it was on slide 12? Is that what you were saying? I printed it, but it's a little bit different. Yeah. Yeah. It just registered to me why you said 12. Okay. Right, so we can make these different prefixes, and then we would set up, just like this is a solution diagram or solution map. If we started with centimeters, then this would be, oh, sorry, I didn't put the, oh, yeah. So 1 centimeter would be 1 times 10 to the negative 2 meters. And then 1 times 10 to the negative 9 meters. Whoops. Is 1 nanometer. And so that would give us final units of nanometers. Okay? Yeah, actually, okay, I'll show you this. I was debating on whether or not to. But so 1 centimeter equals 1 times 10 to the negative 2 meters. We could also say 100 centimeters equals 1 meter. And so this is really whether or not we're writing it with meters on top or meters on bottom. Because if this is 1 meter over 100 centimeters, if we actually type that into the calculator, it will reduce down to 0.01 meters per 1 centimeter. There's kind of two ways that you can write this. If you're using the metric conversion table, though, they're always going to be written where the prefix is 1, so 1 centimeter, and then it'll tell you that 1 centimeter is 10 to the negative 2 meters. Or 1 nanometer is 1 times 10 to the negative 9 meters. Okay, so we got one metric prefix. I'll show you two ways to do this if you're doing one metric prefix. All right, so we're given liters. We want to convert that into milliliters. So because we're starting from one of the base units, we say we can do this in one step. We go straight from liters to milliliters. So 1 milliliter equals how many liters?
I have the answer, but I don't know who to say it. 1 milliliter equals 10 times 11, 10 to the negative 3.
Yeah. 1 times 10 to the negative 3, which is also 1,000th. So you can use that. 1 times 10 to the negative 3 liters, 1 milliliter. You plug it into your calculator. Calculator will say 4.23 milliliters. The other way to do this, and this requires a little bit of intuition. I know that a liter is bigger than a milliliter. If I want to say how many milliliters is equal to 0.00423 liters, then I'm going to move this decimal place over 1, 2, 3 spots. And then that's 4.23 milliliters. Functionally dividing by 1 times 10 to the negative 3, or moving the decimal place over 3 spots, same thing. Okay. Questions? Nope. Two metric prefixes. What's the base unit here? Seconds. S is seconds. So we're working with seconds here. So what is a CS? C, just like centimeter, would be cm. CS would be a centisecond. So 1 centimeter would equal how many meters? 1 times 10 to the negative 2. So 1 centisecond is equal to how many seconds? 0.01, or 1 times 10 to the negative 2. Same prefix, same power of 10. And then how about mu? Anybody know what mu stands for? Mu stands for micro. Yeah, so this fancy little u is mu, stands for micro. You know how many 1 microsecond? -6. So what we're doing is we're trying to figure out basically, if we're starting with centiseconds, our base unit is seconds. So we need the conversion to go from centiseconds to seconds, and then to the desired unit of microseconds. And then we got to cancel out centiseconds, seconds, and then we'll cancel out 1 times 10 to the negative 6 seconds is 1 microsecond. Oops. If you have a TI calculator, they'll use E. Other Casio calculators will have a button that says times 10 and then raised to. It's usually down next to enter. The E and that times 10 to the whatever button both do scientific notation. So here I'm just typing it because I can type it. Oh. So that times 1 E to the negative 2 times, sorry, divided by 1e, it's going to give 6, and hopefully that works. So this equals, wait a second. That did not work. Man, still trying to figure out. Oh. Oh. I see. Because I was just hitting minus. This is good because minus and negative are different things. Assuming that I got them all replaced. There we go. Here's an interesting question. Do I still have the correct number of sig figs? Yeah. Well, helps a little bit. Yeah, so when you're doing metric conversions, it doesn't change your number of sig figs. It'll stay the same. English to English or English to metric makes stuff weird. Okay, so that's 2 metric prefixes. Cool. Units raised to a power. So earlier, I think we talked about how units behave like variables do in algebra. So if I divide something by itself, it cancels out and goes away, right? It becomes 1. Similarly, if I multiply a unit by the same unit, it becomes squared. Just if I did x times x, that would be x squared. If I do centimeters times centimeters, that's centimeters squared. And so part of the measurements lab, you had to calculate the volume of that carton of milk by measuring length, width, and height. So you measured length, width, and height in centimeters, and then you multiply length times width times height, centimeters times centimeters, which gives you centimeters cubed. Just remember, it's real easy to forget that if something's written out, like this square is being applied to the 2.54 and the units, right? Because functionally that's 2.54 centimeters times 2.54 centimeters. So don't forget to square both. This is also important for conversion factors, because if you want to do a conversion factor between centimeters squared and inches squared, because you're trying to convert areas, units of area, you need to square both of those. We'll say it's probably better for you to actually just write out the whole thing, but you could also write it as something like 2.54 centimeters over 1 inch. Square the whole thing that way, because that still applies to every single thing inside the parentheses. And so since we're squaring the top and we're squaring the bottom, then they're still describing, now instead of just describing a length that's the same, they're describing an area, basically a square that's the same. So down here, still going to equal 1. So again, I'll show you 2 ways to do this. So how many cubic centimeters are there in 2.11 yards cubed? So what are we given? Yards cubed, 2.11 yards cubed more specifically. We want to go to centimeters cubed. Depending on which set of conversions you have, again, there's multiple ways that we could do this, because we could go from yards. If we know how many centimeters there are in a yard, we go straight from yards to centimeters cubed. I don't know what that is off the top of my head. Actually, it's 30 something. But let's just use what I know off the top of my head. So if I want to go to centimeters cubed, what's a conversion factor that we know for centimeters to English units?
Inches.
Inches, right? It's the one we've used the most. So that's a good one, because, and now we got to do inches cubed. Really, that only changes how many times we need to do the conversion before we can use it. It's going to still be 2.54, but cubed. So that's a good one for this problem, because yards, I know how many feet there are in a yard, that's 3. I also know how many inches there are in a yard, it's 36. So I can go from yards to inches. So actually we can even close this gap because it's already going to be a little long as is. Okay, so the first way I'll show you how to do this is just using the exponents. So how would I fill in this? Yards at the bottom. And then inches on top. So 36 inches in 1 yard. And then what am I missing? Cube. So we can put the cube out here. I just caution you to remember that the cube is there, and when you type it into your calculator to actually include that. Otherwise you'll get the wrong number. Okay, so now I can multiply that. That'll give me inches cubed. So then how do I get from inches cubed to centimeters cubed? Both of those are correct. Inches on the bottom, and then 1 inch, and then 2.54 centimeters on top. And then we need to cube it. Assuming that we do, in fact, include all of the things that we're supposed to include. I need to figure out a better way to have the calculator on screen at the same time. I don't know. This is going to be 2.11 times 36 cubed times 2.54 cubed and that's just in case you wanted to see how that was written on the calculator. Big number, but we still need 3 sig figs. Okay, just calling out some of the things that I've seen in the past. This 2.11 yards cubed, that's already been cubed, right? I don't need to, this cube is for just the yards. It's not like the whole thing's in parentheses. I don't need to cube this 2.11 when I plug it into the calculator. Okay, so this is one way to do it. This is probably faster, easier to type into your calculator. The other way would be to use the exact same conversions, but then use them as many times as you need to get rid of the full yards cubed. Because if I just do one conversion here, right, 36 inches over 1 yard, I'll just get rid of one of those units of yards. So I'd be still left with yards squared. So then I need to do this again. And then again. Now when I divide by yards 3 times and multiply by inches 3 times, that would give me inches cubed. And then to continue in that same vein, it would be 2.54 centimeters over 1 inch times 2.54 centimeters over 1 inch times 2.54 centimeters over 1 inch. Mathematically, identical. It's the same thing. Moving on. A little bit more complicated of a problem. So vineyard has 154 acres of Chardonnay grapes. A particular soil supplement requires 5.5 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? Gnarly. All right, what do you think we should start with? Just saying start with acres. Say that one more time. Huh? Oh, I see what you're saying. I see what you're saying. Yeah. I think.
That's too much. I would say listen.
Yeah. You're thinking of something like miles per gallon if we wanted to convert that into.
Yeah.
Now, yeah. I see what you're saying. If we try to like make this a compound thing from the beginning. I think you're on the right track with the acres. Start with 145 acres. But maybe we need to decode some of this other stuff first. Yes. Yeah, right. So this 5.50 grams for every square meter. So that's 5.5 grams of soil supplement that I need per square meter, right? Another way we could say that. And so we might want to rewrite that as 5.50 grams equals 1 square meter, 1 meter squared. And then we're given this other one, which is the 1 kilometer equals 247 acres. So let me move this down because we're going to start here with acres. And what unit are we trying to end up with? Kilograms, right? Kilograms. Okay. So just looking at what we're starting with, we've got acres. We're going to end with kilograms. And we've got 2 pieces of the puzzle already given to us, right? So can I fit either of these 2 pieces in yet? Do you know where they'll go? Do any of them have units that we're either starting with or ending with? Acres. We're starting with acres. So we could throw that in here and say we'll go from acres to kilometers squared, or square kilometers. So now for its square kilometers squared, can I relate that to my other conversion factor? Yeah, right? Remember, M for meters. So I can go from kilometers and go from square kilometers to square meters. So we should be able to go from kilometers to meters squared, kilometers squared to meters squared. What would that conversion factor be? Yeah, 1 kilometer is equal to 1 times 10 to the 3 meters. Right? 1 times 10 to the 3 and 1,000 is the same thing. Metric prefix tables, they'll actually generally give you both. Now that's for kilometers to meters. So if I want that to be square kilometers to square meters, I'll have to square the whole thing. And we could do that later. Okay. So that'll get us from kilometers squared to meters squared, right? And then that meters squared fits in here. So if I can get to meters squared, then I can calculate grams. Actually, I don't need to move that away. So then how do I bridge this last step? Can go grams to kilograms. 1 kilogram is equal to 1 times 10 to the 3 grams. And that should do it. That should just solve the problem. Acres to square kilometers. 247 acres. 1 kilometer squared. And then if I want to go from square kilometers to square meters, I need to square that whole conversion. And then for meters to grams, I'll put, or meters squared to grams. 1 meter squared is 5.50 grams. And then we can go from grams to kilograms. So that problem looks very gnarly from the outset because one of the conversion factors is hidden. You got to make some leaps from the fact that this is in grams. Kilograms here, I want kilograms, but I know I can get to grams from that conversion. And that's one of those ones you should know. And same for the kilometers to meters, or meters to kilometers squared. Pieces that you got to fish out of a table or your memory in order to finish this. So this will be 145 times 1 times 10 to the 3 squared times 5.50 divided by 1 times 10 to the 3. Nope, I missed one. and divide by 247. So it will be 3,228.7 kilograms. And then how many sig figs? 3. So this has to be 3.23 times 10 to the 3 kilograms. Hopefully you actually tried to type that into your calculator, just to check and see if you got the same number that I did, or the same number that's on the slide. Any questions? So whenever possible, especially you get a more complicated problem like this, really try and pull every piece of information out and write it out as conversion factors or as numbers. And yeah, there's some just experience that goes into this, but it does help if you think of it like a puzzle. And each conversion factor is like a puzzle piece, right? I can take this kilometer to meter puzzle piece and I can link that with the fact that I can go from acres to kilometers here. And then one piece links to another. All right, okay, so we really only have to talk about just using density as a conversion factor real quick. I know that there's this thing for remembering density that looks something like this. I don't know where the pieces go into that. You figure it out. And I'm not going to get mad if I see you write that on the thing, like on a test or something. If you need that to remember it, you can use that. If you didn't know about it and you go look it up and then you use it, that's fine. But density is a conversion factor, and we can use it just like any of these conversion factors that we've been using. Right? It's got 2 different types of units in it. My density here for this problem is 0.710 grams per centimeter cubed. So that'll let me convert between grams and centimeters cubed of this cooking gas. Actually, maybe I should give you a minute to work on this one. So try to think of density as a conversion factor and not as this nebulous concept. So I'll give you a couple minutes. All right, so what are we starting with in this problem? Oh, yeah. So we want to go from 1.54 liters. That's the number that we're going to start with, the number of the units. 54 liters. And then what are we trying to get to? Ultimately, I think, yeah, for the end of this problem, like kilograms. But as a first step, because we have this conversion factor here, density, that gives me grams per centimeters cubed. So grams is a unit of mass. Centimeters cubed is actually a unit of volume. So that's the key between liters, which is also volume, and getting to grams. So how am I going to convert liters to centimeters cubed? Yeah, 2 steps there. The first one being, should make sure I have enough space. Go from liters to milliliters. And then from milliliters, we can go to centimeters cubed. And then if I can get to centimeters cubed, density lets me turn that into what? Grams. And if I can get to grams, I can go to kilograms. Right. Liters to milliliters. 1 milliliter is 1 times 10 to the negative 3 liters. How many milliliters per centimeter cubed? 1. Numerically, meaning when you do the math on this, converting from milliliters to centimeters cubed doesn't change the number. We do need it. Sorry, that's not. Yeah. Doesn't change the number, but we do need it to convert the units. And then now we can use density. So we want units of grams, so 0.710 grams per 1 centimeter cubed. And then from grams to 1 kilogram, 1 times 10 to the 3 grams. Now you don't have to do this, but looking across at all these numbers that we're multiplying and dividing, can we simplify this a little bit? What happens if I take 1 times 10 to the negative 3 and multiply by 1 times 10 to the positive 3? We cancel out. So while we do need these in order to convert our units so that everything makes sense throughout the process, that part actually ends up canceling out. And so 1.45, I do encourage you to do this on your calculator, prove it to yourself, right? Do it without those, do it with them. You should end up with the same number. But if I do, whoa, yeah, 1.45 times 0.710, it's going to be 1.0295 kilograms. Am I done? Nope. Sig figs. 1.03 kilograms. Questions? No? Okay. Ever onward. This is a good one too. Okay, so very similar to the last one. Drop of gasoline has a mass of 22 milligrams and a density of 0.754 grams per centimeter cubed. What is its volume in cubic centimeters? So we should start with, what should we start with? 22 milligrams. You almost never want to start with the conversion factor. Makes things way more confusing. But if we start with the 22 milligrams, right? Milligrams, I can relate that to grams. So if I'm starting with milligrams, convert that to grams. So 1 milligram is how many grams? 1 milliliter is how many liters? Times 10 to the negative 3. Milli means the same thing, no matter where it's used. And now I can use density to convert to centimeters cubed. Did I write? What do I put on the bottom though? The grams. Yeah, so even density is normally written with grams on top. It's a conversion factor. So that many grams is equal to that volume of whatever it happens to be, gasoline in this case. So I can write 0.754 grams on the bottom and then centimeters cubed on top. And anytime this is written, like here it's written 0.754 grams, and then that's just the slash centimeters cubed, that means per 1 centimeter cubed. So even though the one's not written in there, it's there. So now 22 times 1e to the negative 3 divided by 0.754. And then we got to do sig figs. So in this case, either of these means the same thing and has the same number of sig figs. With small numbers, doesn't always need to be in scientific notation. Okay. Good. Any questions? No? Let's just very quickly look at problems involving an equation. I would like to get to actual chemistry instead of continuing to talk about math. It's going to be more math involved, but the chemistry is more fun. Okay, so some problems involve equations as part of the solution. Sometimes you need conversions also. Sometimes the equation is used to do a conversion. It's the same idea. If you guys have taken any math classes or physics, lots of equations. Just to look at some equations In chemistry, we can convert between different temperature scales, which is weird because Fahrenheit and Celsius, it's like a change in temperature of 1 degree Celsius is a larger change in temperature than 1 degree Fahrenheit. So that's why the scale here is so wonky. So this first part, and sometimes this is how I just remember this, instead of memorizing it, right? Why do you think we need to do degrees Fahrenheit minus 32? Because freezing is different in Celsius and Fahrenheit. So Fahrenheit's 32, but Celsius is 0. So Fahrenheit minus 32 brings the Fahrenheit freezing point down to the same as Celsius. But then we have another issue. Like I said, the difference in 1 degree C is not the same as the difference in 1 degree Fahrenheit. And so this next part, actually maybe I had it backwards. Maybe Fahrenheit? No, Celsius is bigger. Anyways, this next part, dividing by 1.8, brings those two into alignment. So now it takes the Fahrenheit and it changes the size of it so it's the same as 1 degree Celsius. And so with that equation, plug in Fahrenheit, find degrees Celsius. Kelvin to Celsius is way more straightforward. What's the significance of 273.15?
Absolute zero.
Absolute zero. So we'll talk about this later, but temperature is really the kinetic energy of atoms and molecules in motion. Absolute zero is when you cool them down, those atoms and molecules slow down, right? And if you cool it down enough, they don't like stop and then reverse and move in the opposite direction. They just stop. That's absolute zero. So even deep space is 2 or 3 degrees Kelvin. Sorry, I said degrees Kelvin. It's just 2 or 3 Kelvin. There's no degrees. What this does is, if we want to get to Kelvin, 0 in Kelvin is absolute zero. 0 in Celsius is negative 273.15. So if I take degrees Celsius, add 273 to it, basically shifts the whole thing over so that it's now Kelvin. Okay, so just very quickly, because these are just formulas. So gallium, solid metal at room temperature, but melts to a liquid in your hand. The opposite of M&Ms. The slogan for M&Ms, melts in your mouth, not in your hand. Yeah. Apparently not. The melting point of gallium is 85.6 degrees Fahrenheit. What's this temperature on the Celsius scale? So we need the equation. So degrees C equals, first we take degrees Fahrenheit, we adjust it so that 0 is the same, and then we divide by 1.8. 85.6 degrees Fahrenheit minus 32 divided by 1.8. And this is a calculator skill check, because if you type that all in one single line, something like 85.6 minus 32, and then you say divide by 1.8, the calculator will do the division first and then subtract. Maybe I should write this with parentheses. That's why the parentheses are there. So if you do parentheses here, it'll do the correct order of operations. Or if you have a fancy calculator that'll let you put stuff over fractions, that'll work too. 29.8 degrees C. So what's that on the Kelvin scale? Well, just take 29.8 plus 273.15. Oops, plus. Oh. Ah. Okay, so I played myself. The actual answer here, maybe I looked at the slide, automatically did the sig figs. So this is actually 29.777 repeating. If you do this, like I did here, with correct sig figs, this is 303.0 Kelvin. If you do it as 29.77, that's how you get 302.9 Kelvin. We will have more equations later, and so we can look at that more later. But I feel like everybody should be familiar with how equations work. You replace the one thing in the equation, solve the equation. All right. Took longer than I was hoping, but